Okay, here's a special limits problem that I wanted to look at, AP Calculus AB. So let's take a quick look at this, and it asks us to compute this value. So compute the limit as x approaches 0 of the opposite of 4 over sine of 2x plus cosine 2x. So I'm going to start by doing this. Let's take a look and see what happens here. We have negative 4 times, well, this should be x here, times 0 all over sine of 2 times 0 plus 0 over cosine of 2 times 0, right? And we get 0 over sine of 0 plus 0 over cosine of 0. Some of this is not bad news. This is not bad news because this goes to 0 over 1. That's defined, so we can deal with that. We can use that. That's 0. But this is undefined. We get 0 over 0, the indeterminate form. So since this is okay, we're just going to deal with this part. So let's just take a look at this now. And let's take this limit. Let's take the limit as x approaches 0 of the opposite of 4x over sine 2x. Remember that this is a special limits problem. How do I know that? Because sine of x over x is equal to 1. Really, really important to know. So let me make a star out of that. Really, really important fact to know for this test. However, in this case, what I'd like to do is this. We're going to multiply by a coefficient of 1/2 to get to this point. So we're going to do this. We're going to take negative 1/2 times the limit as x approaches 0 of negative 4x over sine of 2x, right? Will give us the limit as x approaches 0 of 2 over 2 sine 2x, right? Which will give us, 2x, which is equal to 1, isn't it? Can you see this here? So we can keep moving if you like and take this 1/2 times the limit as x goes to 0 of 2x over sine 2x equals 1 over our negative 1/2 here to get us back to where we started, right? And we're gonna get this. We're gonna get equals, is equal to 1 over negative 1/2, which is equal to negative 2. All right. So what we really did here was go over this special limit. So I'm hoping that this was helpful. Your comments are welcome, and I want to thank A. Burton for his work on this problem and B. Murray. So thanks, you guys. Great work.